So, this is our problem statement. Our problem's title is Optimal Cable Network for a Suburban Neighborhood. A suburban neighborhood of 8 houses needs a cost-effective cable network that connects all houses with minimal installation costs. The task is to determine the most cost-effective way to connect all houses without creating a redundant connections. Each house is represented as a node, and the cost to lay cables between houses is represented as the weights of the edges connecting these nodes. As you can see, this table mentions each pair of house and the distance between each one of them. So now, we must find the most cost-effective way to connect all the houses without creating redundant connections, which means we should find the minimal spanning tree, which is our topic, from the graph. We have two types of algorithms to solve this problem. The first one is Prim's algorithm, and the second one is called as Kruskal's algorithm. First of all, we represented all the data that we get from the table into a graph. We used visual graph software to make our graph realistic. It is because this tool is so easy and user-friendly to use.
Alright, next off I'll be talking about Prim's algorithm. Prim's algorithm is an algorithm that finds a minimum spanning tree for a connected, weighted, undirected graph. This basically means it finds a subset of the edges that forms a tree that includes every vertex, where the weight of all the edges in the tree is minimized. Prim's algorithm is an example of a greedy algorithm, and the algorithm are as follows. Step number 1. Pick any vertex as a starting vertex. Call it A. Step number 2. Find the edge with the smallest weight ingredient to A. Color the edge to the next vertex. You can call it B. Okay, the last step is to find the edge of smallest weight increment to either A or B. Call it vertex C to convenience yourself. Repeat the step by choosing the edge of smallest weight that does not form a cycle until it spawns all the vertexes. The resulting subgraph is a minimum spawning tree.
As the first step of Prim's algorithm, vertex A has been chosen as the starting point of the graph. After that, B is the vertex nearest to A, which contains a weight of 10, and will be chosen as the second vertex along with edge A and B.
After that, D is the vertex nearest to B, which contains a weight of 20 and will be chosen as the third vertex along with a edge BD. After that, C is the vertex nearest to D, which contains a weight of 5 and will be chosen as the fourth vertex along with a edges. HDC. After that, E is the vertex nearest to C, which contains a weight of 10 and will be chosen as the fifth vertex along with the edge CE. After that, F is the vertex nearest to E, which contains a weight of 30 and will be chosen as the sixth vertex along with the edge of EF. After that, H is the vertex nearest to F, which contains a weight of 5 and will be chosen as the seventh vertex along with the edge FH. Lastly, G is the vertex nearest to H, which contains a weight of 30 and will be chosen as the last vertex along with the edge HG.
So, as you can see, this is the final test result that we get from using the Prim's algorithm. The total weight of minimal spanning tree of this graph is 110.
Hello everyone, today I'm going to talk about Kruskal's algorithm and the steps of Kruskal's algorithm. Kruskal's algorithm also constructs the minimum spanning tree of a graph by adding edges to the spanning tree one by one. The edges are selected and added to the spanning tree in increasing order of their weights. An edge is added to the tree only if it does not create a cycle. The beauty of Kruskal's algorithm is the way that potential cycles are detected. The steps of Kruskal's algorithm are: firstly, find the edge in the graph with smallest weight. If there is more than one, pick one at random. Second one, find the next edge in the graph with the smallest weight that doesn't close a cycle. Color that edge and the next incident vertex. Lastly, repeat step 2 until you reach out to every vertex of the graph. The chosen edges from the desired minimum spanning tree. Thank you.
CD and FH are the shortest arcs, with the length 5, and CD has been attributively chosen. Then FH is chosen as the second edge.
As the second step, AB, CE and FG are the shortest arcs with length of 5 each, and CD has been arbitrarily chosen. AB is chosen as the third edge, followed by CE as the fourth edge and FG as the fifth edge. So, as you can see, this is our final answer that we got using Kruskal's algorithm. The total weight of our minimal spanning tree is 100. So we can decide that Kruskal's algorithm gives more accurate answers than Prim's algorithm. At last, we would like to attach a video of how we managed to make a graph using Graph Online software. This website helped us a lot with the graph. This is a user-friendly website where we can make our graph using the data and metrics of the data that we get from a table.